So let's proceed now to our example number 11 or situations number 11. So let's analyze first the problem. So a plate 75 mm wide and 12.5 mm thick is joined with another plate by a single traverse weld and a double parallel fill-in weld as shown in the figure. So diniscuss naman natin kanina kung ano yung itsura ng single traverse and a double parallel fill-in weld. So it is a combination of the two. So the maximum tensile and the shear stresses are 70 MPa and 56 MPa respectively. Find the length of each parallel fill-in weld if the joint is subjected to both static and fatigue loading. So dalawa yung nahanap natin dyan, yung length ng each parallel sides in terms of static and fatigue loading. So let's proceed to the next slide. So nilitan ko lang ang ating sample problem para marami tayong space sa pag-solve. So, ano natin ginagawa pag nag-solve tayo ng problem? Siyempre, i-state mo natin yung mga given values. So, for our given values, we have the width of 75 mm and our thickness is 12.5 mm. And our tensile stress that denoted as sigma sub t is 70 MPa and our shear stress that our symbol is tau is equal to 56 MPa. So, let's discuss first the effective length of the weld. So, gagamitin kasi natin yan. So, the effective length of the weld is, of course, ang width is ma-minus natin sa thickness. So, 75 minus 12.5 mm is equal to 62.5 mm. So, L2, ito hahanapin natin. Length of the each parallel fill-it. Sorry, nabubulol. So, yun. So, let's discuss first the length of each parallel fill-it weld for static loading. So, pinagsabi natin static loading, a load that doesn't not change over time. Ibig sabihin, hindi gumagalaw. So, yan. So, let's compute first the P or the force P, where is area times stress for 75 times 12.5 times 70, which is ito yung area niya, width times the thickness. So, we can get the 65,625 Newton. So next is, so etong una na to, for ano to? For single traverse. Single traverse. Yan. Hindi ko lang naisulat siguro. So yan. So natatanda natin yung formula natin na to kanina. So ilagay lang ulit natin sa formula. So ang double natin is 12.5. Ang L natin is 62.5 or the effective length natin ng weld, and our tensile stress is 70. So we can get 38,664.06 Newton. So for number 3, ito yung natawag nating double parallel fill-it weld. Sinasabi sa problem, ito. Double parallel fill-it weld. So kaya meron ditong times 2. Yan. So, ilagay lang din natin ulit yung values. So, di ba ang hinahanap natin L2? L2 na hinahanap natin dito. Kasi di ba pagka sinabing shear, parang kumakaskas, di ba? So, yon. Ilagay lang din natin ulit yung tau natin na 56 MPa. So, we can get the P2. And then, this is the P1. Kasi this is in terms in tensile stress and this is in terms of shear stress. Kaya magkaiba sila ng length na ginamit. So, isipin natin, paano natin makukuha ngayon yung values ng L2? So, kapag in-equate natin ng P is equal to P plus P sub 1 plus P sub 2, may isip natin na makita natin makuha yung L2. Yon. Kasi meron tayong nakuhang P at meron tayong nakuhang P sub 1 at meron tayong nakuha P sub 2, which is P sub 2, meron tayong unknown values na, which is L2. So, lagay lang din natin ulit, 65625 is equal to 38,664.06 plus 989.8 L2. So, lipat lang natin to sa kabila and then divide natin. So, we can get the L2 is equal to 27.24 MPa. Pero hindi pa ito yon. Kapag nakuha natin yung values natin ito, ipa-plus pa natin ang 12.5, which is the thickness, para makuha na natin yung length ng parallel fill it for the static loading. So we can get 39.74 mm or we can say 40 mm. So nakuha na natin yung length for static loading. So next, we can get the length of the each parallel fill it for fatigue loading. So pag sinabi naman natin fatigue loading, it is changes observed in material under the influence of stress. Ibig sabihin, gumagalaw na, ganon. So dito na papasok ngayon yung concentration factor. Concentration factors. So for traverse weld, we have 1.5 and the parallel fill it weld is 2.7. So, para mas maintain natin lahat is meron tayo ditong table. So, yan. Meron tayo ditong stresses concentration factor. So, kapag ka-reinforced butt welds, ang concentration factor niya is 1.2 and for toe of traverse fill it welds 1.5 and the end of the parallel fill it weld is 2.7 and the T-butt joint with sharp corner is 2.0. So, for static loading in any type of joint, stress concentration factor is 1.0. Kaya kanina hindi na natin to ginamit. Kasi 1.0 naman din siya. So, hindi naman siya magkakaroon ng difference. So, let's compute first the permissible tensile stress. So, ang tensile stress natin is 70 MPa. So, i-divide lang natin siya by 1.5. So, we can get 46.67 Newton per millimeter squared. And then for permissible shear stress, i-divide lang natin yung 56 MPa into 2.7 so we can get 20.74 Newton per millimeter squared. So next. So we can get now the load carried by single traverse weld. So yan, nakasulat na. So for single traverse weld, sorry, nabubulol. So, for P1, ito lang din yung formula natin na tatandaan natin kanina. So, ilagay lang din natin ulit yung mga values. So, for the W, the L1, and the stress. Yung 46.7 natin nakuha din sa permissible tensile stress. So, we can get 25,794.45 Newton. So, for load carried by double parallel weld, times 2 kasi double ulit. Double parallel weld. So, kaya times 2. So, ilagay natin ulit yung W, which is 12.5 or the thickness yon yung W. So, L2, ito yung nahanap natin. And then the permissible shear stress, which is the 20.74. And then we can get 366. Wait, let me double check it. Wait for a while. Yeah, 366.58 L2N. Sorry, medyo nalito. So, next. So, we can now get the load carried by joint P. So, yung kanilang din natin ginawa. So, kasi na ba yung cursor ko, nawawala yun. So, for load carried by point P, so, ilagay natin ulit yung equation natin that P is equal to P1 plus P2. Ito, nakuha natin ito kanina sa may una natin. 65,625 is equal to P1 plus P2. So, for our P1, ito yung values niya. So, for our P2, ito. And then for our P1 and then P2 is ito. Sorry, nalilito. And then, we can get that our L2 is 108.65 mm. Pero hindi pa ito yung final answer natin kasi ipa-plus ulit natin ang 12.5 para makuha natin yung length ng each parallel fill it natin for fatigue loading. So, our final answer is 121.15 mm. And then yung nakuha natin kanina is 40 mm for the static loading. So, ito na yung answer natin. Yan. So, let's proceed to the next.